This video is about quadratic and polynomial functions. Now, quadratic is a particular kind of polynomial function. So we'll start with polynomial functions. A polynomial function of degree n, with n a non-negative integer, is given by f of x equals a sub n times x to the n plus a sub n minus 1, x to the n minus 1, plus a bunch of other stuff, that's what the dots mean, plus a sub 1x plus a sub 0, where all of the a's are real numbers and a sub n is not 0. So that's how we write a technical definition, but there's a couple of things that you should just be sort of zoning in on here. First off, when you see something like this and it says these are real numbers, what you should think is okay, this is something like 5x to the 3 plus 18x to the 2, okay? A sub n is just some real number. A sub n minus 1 is some real number. The point is that the powers are going down. And this requirement here, that n be a non-negative integer, sort of makes sense. We're looking for powers being numbers that are integers and not negative. So that's what's going on. Notice that the thing that I wrote in red here, the degree is the highest power of n that shows up in a polynomial. One other sort of term that I want to tell you about or remind you of if you already knew, the coefficient in front of the x term with the highest power is called the lead coefficient. That'll be helpful at various times in the future. Okay, so those are polynomials. Now we have a whole bunch of different kinds of polynomials and we talk about them by the degree. A degree 1 polynomial is called linear, okay? And an example of that might be something like f of x equals 2x plus 1. Can you see that the highest power of x that appears there is x to the 1? Now, degree 2 is called quadratic, and I bet you already knew that. And I probably didn't leave myself enough space to write one there, but you get the idea. We can have f of x equals 7x squared plus 2. Now you might say, hey, I didn't write an x term. Well, that's just fine. These middle terms can all be 0. But the first term can't be 0. If the first term was 0 on this quadratic, then it wouldn't be a quadratic. It would be linear, right? And then degree 3 is called cubic. We'll give ourselves a real softball here. You could even have that lead coefficient be 1, so you could just write x to the 3rd. And all the other ones are 0. Degree 4 is called quartic. Degree 5 is called quintic, and we probably don't care that much. This is about quadratics. Quadratic functions, they have up to 3 terms in them. You might have them, in fact, you've seen them before, that look like this. 2/9 x, so they have a quadratic term, a linear term, and who knows, just to emphasize, pi, that's 3.14159 on forever. These don't have to be integers, they're real numbers, right? But you have number x squared plus number x plus real number, right? Okay, this is what's called general form. And that's the form that, say, you would run the quadratic formula out of. There's A, there's B, there's C. That's the form that usually it's easier to factor into 2 parentheses to find the 0. That form is useful for a lot of things, but there's another form. It's called standard form. that has some strengths also. Okay? Standard form is going to look like this. F of x equals, here's just one example, 5x minus 2 squared plus 3. Okay? Now, can you see that if you expanded all of that out, if in fact you multiplied x minus 2 times itself, then multiplied that entire thing times 5, you'd get an x squared term, you get an x term, and you'd have constants, right? So this could be rewritten in this form. This form is particularly easy because you can read out of it the vertex, and you can also read something out about how much it's stretched. But the key thing is the vertex. Now, a quadratic equation is always going to look like a parabola. It might be cupped upwards or cupped downwards. This is one of those places where the lead coefficient is really relevant. If the lead coefficient is greater than 0, it's always going to be cupped upwards. Now, if you know it's cupped upwards, just sort of a really rough picture, wouldn't it be nice to know this point? That point is called the vertex. Over here, there's a little more work to find the vertex, but here, there's really very little work to find the vertex. Notice the lead coefficient is going to be 5. If you multiply it all out, it'll still be a 5 in front of the x squared term. So I know this is cupped upwards. In this example, what happens is I can read off the x value of the vertex and the y value of the vertex quite easily. So notice this is x minus 2. If you thought about that as a shift, this might be one way to think about it. Think about the equation f of x equals 5x squared. Well, you know that that looks something like that. That's a vertical stretch, okay? And then what does a negative 2 on the inside do? Well, that shifts you right 2. What does a plus 3 on the outside do? It shifts you up 3. So we happen to know that this equation here, might get a little messy because I'm drawing over my own work, looks like that. So just roughly speaking, knowing where the vertex is really easy in standard form. Now, this is an example of standard form. In general standard form, for a quadratic function is usually written f of x equals a is the lead coefficient, x minus h squared plus k with vertex at hk.